Welcome. Thanks for coming to my talk on mobile database persistence. My name's Eric. I work for a company called Big Nerd Ranch. We're an education company and a consulting company. So we do books, we do in-person training, we do online video training, and then we also do a lot of just software development for companies around the country. This talk is mostly about using Room, but it's also about a history of where we've come from. And given how easy Room makes it for us to do things with databases, things that we still want to kind of make sure that we're looking out for as we're developing our applications on top of a Room database. So we'll start out specifically with kind of a brief history of time looking at up until 2017 what our first-party library options were. Then we're going to talk a little bit of an intro into Room and how nice it is to develop for SQLite databases on Android using Room. And then I'm going to spend a lot of time interactively talking about the importance of good database design and some things to consider when you're creating your Room objects. And then just a few things at the end. I'm just going to talk about some integrations which I think are really, really dynamite with Room that if you're not already checking out, I think you should. Throughout this, I also want it to be very interactive. So there's some times where I'm going to actually ask you all questions, and we're going to figure out what the right answer is to how something will work. And if you have a question throughout, feel free to raise your hand. Let's take some time to actually talk through some of this stuff. I wouldn't say by any means that I'm a Room expert, but I've been using it long enough that I feel pretty comfortable in it. Okay. All right, so let's talk about back in the day. Back in the day was actually not that long ago, pre-2017. We had three main helpers, first-party support, for working with databases on Android. We had this thing called a SQLite Open Helper, and that SQLite Open Helper created hooks for us to create our database when it was first installed on the user's device, and a hook to upgrade that database if, say, for example, we had made a release that created the database, and now we've altered that database and put it into a new release. There is a method to hook in there to put our alter table statements, create new tables, transfer that data, et cetera, so the user didn't lose data. The one thing that you'll note is that back then, with SQLite Open Helper, we had to manually create the database ourselves. We had to, define those create table statements. If we had relationships, foreign key constraints, any of that, we had to define that ourselves. But it gave us a nice, convenient way to put that in, which if you think about the alternative, which was basically finding the database on the file system, opening it up, there's a lot more things that you could have had to do. So this, for its time, was a pretty good tool above, to abstract pulling that data out. To insert and update was a little bit of a different story. We had to work with things like content values maps that you see up at the top to put in key value pairs for things we wanted to put into the table. Then the insert itself wasn't too bad. We would mention the table name and pass those values. But the queries is where things got a little complex. It supported a query method that you pass the table that you wanted to get objects out of, and then you just pass basically this string to set only pull results out where the column ID equals, for example, this insert ID, et cetera. So you'd end up with classes that looked really big like this just for simple CRUD access to your database. So what people did, and by the way, this is intentionally shown very hard to read just to illustrate how much code goes into a simple create, read, update, and delete against your database. So typically, people would go to third-party solutions, and there's nothing wrong with that. In fact, Google really encourages it. For example, for network RESTful like if you're consuming RESTful services, they encourage you to use retrofit, right? Because there's a great third-party tool to do that. But developers had really wanted some better first-party support for working with databases, so they came up with Room. Now, before we show Room and how much nicer it is since 2017's announcement, I just want to stress that even though there is a lot of work that went into working with databases through these helper classes before, at least we kind of knew our table structure. It forced us to kind of think about how things were related, right? And we'll see with Room, it's so easy. It's easy to also forget about all that work that we used to have to think through. So enter the modern age. So in 2017, as I mentioned at Google I/O, Google announced Room, the official database wrapper, or ORM, for us to use when working with a SQLite database. So first up, by show of hands, how many people have started using Room? A couple. How many people have heard much about it or how it works? A couple more. Okay. Well, that's okay. I'm going to give a quick kind of intro. So basically, it's kind of shown reverse. Normally, you'd show the database at the bottom, and I actually pulled this graphic from the developer.android.com site. But basically, your database is shown here at the top level, and there's a layer of abstraction around it. And that layer of abstraction is this Room kind of database engine, database wrapper. You define all of the table structures that you would have in your database with these things called entities. They're just Java or Kotlin objects, and you annotate them to indicate how that translates at the database level to tables and how they're related to each other. And then the application goes through something called a data access object. Now, a data access object, it's important to remember, all that is a pattern. It's not a new pattern. It's a pattern we've been using for a long time. But the really cool thing is that Room kind of adds some tooling around that such that you just define an interface saying how you want to access your data, and it goes through all of that work that we used to have to go through with like cursors and content values maps and all that stuff. It makes it trivially easy to work with the database. So let's take an example. So let's say I had a simple person table in my database. And this person has some information, an ID, which is, let's presume that this is an auto-generated auto-increment ID, because SQLite basically supports an auto-increment unique ID system for its primary keys. So if you don't specify one, it'll get generated for you on insert. And then let's say it has a first name, last name, and a birthday, which is a date stored as a long. So that might look something like this in SQL. To model this in Room, you would just define a person class. And you indicate that this is a persistent entity with this annotation that's just an entity at the top. All of your properties on that object become columns in the database. If you don't want it to, there's an annotation to ignore a specific property. But otherwise, they just become columns in the database. And there are hooks to control some of the naming and some other things about these things. So for example, if I didn't want camel case, which in the database it's not common to do camel case, I could force it to be snake case as the column names. Notice for the primary key, you can specify something called auto-generate. Does anybody have an idea what auto-generate does, how it generates the key? Anybody want to take a guess? That's a good guess. Yeah. Yeah.
Default thing to that auto-increment?
Yeah. So basically, if you supply auto-generate equals true, it's probably a little bit hard to read there. But as part of the SQL statement, it adds that auto-increment there. So I should also say that recently, within the last 6 months or so, I was involved with a project that was already using Room. And there were a lot of surprises, I think, to the team when I came in and saw some of these things. It was kind of nebulous how auto-generate actually worked. And they thought, well, there's some magical thing that Room is doing to auto-generate this key. And it turns out all Room does is really just wrap calls to the database. So the database is doing all the work here. So anyways, that's how you would use the auto-increment feature of SQLite, just by turning it on here. And you can see here too that we can also enforce that the key is not null, and this can be done with a standard non-null JSR annotation. Questions about the entity?
Do you have a choice on what kind of format you would use for your IDs?
You do. In fact, I have it in a couple slides, but you can make it a string, for example, if you would prefer over an int. You'd have to supply your own. It can't auto-increment that. But you could do that, just use a UUID or something like that. Yep. OK, so let's look at our DAOs. So this looks much nicer than a full page of code, at least to me. And the reason that this works, you'll notice that this is an interface. What happens is there's a lot of annotation parsing, compile time, build time annotation parsing that happens here. And Room, when it builds your project and it's configured to look for these DAOs, it will take those and it will generate an impl class that does all the hard work of working with cursors and translating those back to objects, et cetera. So it's really kind of cool and powerful, everything that it's doing. And you just define a simple interface with like how to get all people, for example, or how to find a person by their ID. So this becomes very simple to set up. And the other cool thing about this is you might be worried about, well, actually, we never had this to begin with, but you might be worried about, what if I have a mistake in my SQL? Like, what if I said selects, plural, right? Selects star from person. It turns out that during the build time, this will be caught and flagged. This will be underlined in red, and you can't build it because it will actually parse your SQL here to make sure it's valid. And it's not just for syntax, too. If I put persons or people and the actual database table name is person, it will also give me an error there and says, I don't know what a person's is. You have just a person table, but you don't have a person's. So this is kind of neat. When you're defining these, you can know at build time that you've defined a query that will at least run. It might not return the results you expect, but it's at least going to run. And then you can see how dead simple it is for insert, update, and delete. You don't have to build that content values map anymore. You just pass a person, and they're inserted or deleted, et cetera. And you have some flexibility on the return type. In this case, for insert, I have it returning a long, so that would return the ID that was generated by that auto increment key. Does that make sense? OK. Your queries can get pretty complex. This one is the second one that I actually took from the developer.android.com site. But it just kind of goes to show you how you could join on multiple tables to pull back things that made sense for your query. And then you could just name the method something that's like meaningful so that a caller to this DAO could just say, hey, find books borrowed by name. In this case, it's synchronously. And I'll explain more about that towards the end. OK, so you had asked the question about flexibility on keys. Well, if I leave that off, then it takes out the auto increment. I can change the ID to a string, and it will basically change what the ID is to a varchar in the database. Or I think a varchar 2, actually. That might be a typo. If you're not familiar with Kotlin, this is just like doing type inference to make this a string. I could have explicitly just typed it as a string, too. So there's some options there. Yeah?
I had a question on your previous slide.
Yeah.
Or one more.
This one?
Yeah, the select asterisk from book and with all the joins.
Yeah.
Is the return basically an object that represents book, joined to alone, joined to users, since it's not specified there? Or is it just whatever properties fit your book model, if you will? Or I don't know if you want to call it DAO or.
Yeah.
Like, what's returned here? I'm sorry.
No, that's OK.
Fits into one book and then a list of them, and then everything else is just kind of ignored that exists in loan or user tables?
That's correct. So yeah, so just to kind of repeat the question, what's actually returned from this SQL where you have a join with a bunch of different columns coming through? In this case, your return type is a list of books. You can't really do, like, it's not as free as like SQL in the sense like you can't just like pull together columns from like 10 different tables or 4 different tables or whatever and put them back into what would be an entity here. There are some things you can do, like if you want to return a single value, like you can pull back, like just say like a person's name and have it return like a string, for example, or if you want to look for all people with their names named Bob or whatever, you could have a list of string returned, and then in your select, you'd want to make sure that that's the column you pull back, and that would all kind of work out. But by and large, you pull back an entity, and then the other things that you're joining on are just meant to kind of like filter that out. Any other questions? Okay. So we saw the keys. Okay. So that's all well and good. Now I want to talk about relationships, right? Let's start with a very simple one-to-many relationship. Let's say that I had a person table and I had a pets table. And so each person has 0 to many pets, and the pets belong to a single person, okay? And let's say that I had set up, normally I would set up these constraints in the database if I wrote my own SQL, but let's say this was the relationship, okay? If I define my entities like so, where I have a person with their ID, first name, last name, birth date, etc., and a pet with an ID, person ID, right, for the person, name and skills, then I could, for example, create a query that joins the person on the pet and looks for, we're basically looking for people with pets possessing certain skills. And we could set that up for a method, and then we could grab a list of people with amazing pets passing in these skills, right? Makes sense, right? So my question, though, is, are these things actually related? The join query worked, right? And obviously, this is a person ID, so they must be actually related in the database, right? I see a few heads shaking no. Anybody think yes? Okay. The answer is no. They're not actually related in the database. And I've seen this happen many a times where you have entities, you've defined a foreign key that points to the parent, and yet they're not actually defined in the database. And you might ask, does this even matter, right? Like, why? If I'm querying these out, like, what's the big deal? Can anybody think of why it might matter? Yeah. Orphaned records, that's exactly it. What happens if we delete Bobby? What happens to Bobby's pets? They're just sitting around orphaned, and we're not cleaning those up, right? So you either have to do that manually, which is a bad idea, or you can set up foreign key relationships. And again, just to kind of reiterate the point, what if you had a many-to-many relationship? Well, it turns out you have to create another entity to map that join table. Again, you'd have orphaned objects or orphaned rows, and you don't want that, right? And if that's not enough to convince you, maybe for this simple example, you could do, delete in the same transaction for both, tables. Think about scale. Think about as you have, a person which might have 0 or more addresses and phone numbers, and then you have a many-to-many relationship between them and their pets, et cetera. Now you delete a person, you're going to go and delete from the address, the phone, and the person pet separately. That's not really where you want to be doing that. There might be some special cases for certain use cases in your app or certain apps, but for the most part, you want the database to do that, right? Like that's what it was designed to do. So you can do that very easily, but you have to do that. You have to remember to do that. And I've seen on code where people don't do this, and then they get into a situation where they're deleting 8 different records from 8 different tables all at the same time. But it's pretty easy to do. Inside of your entity tag, there's a foreign keys value you can set inside here, and that's just an array of foreign keys that you can set. You set the entity on that foreign key to the entity that you're pointing up to, like your parent, and then the parent column, which in this case would just be ID, and for this specific example, the child column would be this person ID, and then you define what happens when, say, like it's deleted, and I'm not showing on update, but you also have that available too. Questions about how that's defined or why we need it? Okay. So Cascade does what you think it would do. It would, when you delete the person, it deletes their pets. You also have set null, which is a very common one I've seen. You can set the ID to null. It has a bunch of others too, like you have restrict, just like you would in any other database environment. Although personally, and somebody correct me if they've found a good use case for it, it feels to me like restrict, which would, in this case, prevent you from deleting a person before you deleted pets that are pointing to that person. It seems like that doesn't make as much sense on mobile unless you're trying to force your future developer self to remember to think about relationships, but otherwise, like, there's no reason that you wouldn't want to either set it null or cascade, right? Typically, in my experience, like, restrict would be for, you know, a shared tenant database in a network somewhere where you have a bunch of apps pointing to it and you want to kind of have some sense of control there. But has anybody actually used restrict for their foreign keys on a mobile app? No? Okay. Okay. So I want to move into another thing, which is performance. Again, this might seem obvious if you've been doing database development for a while. But again, I've seen this when we have, like, let's say we had a person defined. Maybe it's the same person, but I'm just going to show you two properties here. The ID, obviously, and the first name. Let's say we set up a query for that, and we said select star from person where their first name is the first name that you passed in here. And let's say they were looking for John, right? This record here. What's the issue here? What's going to happen when we issue this request? Yeah, full table scan, right? That sucks. That's going to take a long time to go through the entire table to find that. It's very easy to add an index. All you have to do is add on to that column info, say index equals true. But you got to remember to do that. So the point I'm trying to emphasize here is that Room is amazing. It is so easy to do this stuff. Like, it's very trivial, very quick. There's very little code you have to put into your app. But you do have to think about these things and not forget about these basics. The next thing I want to talk about might be some more, I guess, kind of gotchas here, consistent data. All right, so let's take another example. And in this case, if you have a more complex index that you want to set, like whether or not you want to set it to true or false for uniqueness, or even like compound index and keys, et cetera, you can do that. And you would do that at the entity level. And so let's say for this example, I have a person defined, and I am setting an index on their first name, and I'm saying that their first name has to be unique, right? Then let's say I had a DAO method for insert, and for this experiment, let's just say that the database is empty before we run it, and I'm going to insert these 3 rows, right? Or attempt to, at least. So I put in the first one, so we have a Bob in the database, and their ID is 1. I put in the second one, we have a Charlie in the database, their ID is 2. What do you think is going to happen when I try to put in another Bob with their ID 3? Well, it actually depends. And to be honest with you, I'm not sure the sensible default, but it depends on your conflict resolution strategy. My recommendation is to avoid any kind of surprises on what the default might be, and just specify it yourself. But yeah, if you had set some sort of rollback or abort strategy, it would have thrown an exception, it would have rolled that back. But if you say replace, you can actually just replace the record, and you'd have options 2 and 3, or rows 2 and 3 in there. There's also abort, which would take the first 2, and Bob wouldn't get in there. And you basically have all of these options available. All these options, most of them aren't controlled, if not all of them, aren't controlled at the room level. This changes well, some of these are like rollback, but like this changes how some of the SQL statements are generated. So for example, if you use replace, the actual statement that gets run is not exactly, well, you're not defining a statement, but if you did, it would change a bit. It's going to do insert or replace into yada yada versus insert or ignore, et cetera.
Does ignore just not act on your request? What is it?
As far as I can tell, ignore just silently doesn't do anything, so it's not the best option. In practice, I've only used rollback or replace. Yeah, I haven't experimented with the others in practice. But these are all the options. If you follow basically the API for this conflict strategy, these are the options and documentation for them. Other questions? Sure. Okay. All right, so let's talk about transactional integrity. Before we get into this, let me tell you that everything you do in Room runs in a transaction. So keep that in mind as we go into this next phase. Okay, so now I have a multiple choice quiz here, okay? We're going to do it together, so it'll be kind of fun. I have a person table with other things, but they have a first name property / column. It must be unique, so this is no different than what we just saw. I have a conflict resolution strategy of rollback, and I have a function that's going to save people, and I'm going to do these three over again. So my question to you is, knowing everything we know and setting this up, are we going to end up with what's behind door number A, or letter A, B, or C? How many people say A? Oh, is that a question, or? Oh, raising for A. Okay. Anybody else? Oh, A? How many A's? Let me see the hands. Okay. How many B's? Ooh, it's like half and half now. I'm not sure. How many C's? Yeah, because obviously that's a problem, right? It's unique. C was like it's like when you're taking like the SATs or ACTs, you like throw out the ones you know are wrong. So we'll throw out C very quickly. Okay. So which one is it? Well, it is true. I didn't lie to you. Everything in Room runs within a transaction. However, each of these DAOs run their own transaction. And this is something that is very easy to miss. When you're first getting started on Room, I've seen this happen. People don't really realize this nuance. So what would actually happen is one transaction would be started, Bob's inserted. That's great. Another transaction, Charlie's inserted. Fantastic. Another transaction, ooh, this is bad. Let's roll back that transaction. But now we've been left with like half a transaction, half of a real transaction in our database, right? So that's obviously not what we want. So what can we do?
What do you mean by half of a real transaction?
Oh, yeah, I probably shouldn't have said it like that. I'm talking about from like a use case business requirement. Like, let's say I had a use case to put in a full list of people into my database, right? Like,
You're talking about the method itself.
right, yeah, and I'm just saying, like, right now, if my use case was to save all the people who showed up at the party, say, right, then I've saved 2 people, but my job was to save everybody or nobody, right? So it's not atomic, it's not one unit. That's all I mean.
Got it.
Yes?
One question, in the save people function on the third line,
Mm-hmm.
when that fails,
Mm-hmm.
does it fail silently, or is there some result, or does it throw an exception?
Exception, yeah. So you'd at least know about it. But when you knew about it, you'd have to be like, well, crap, now I got to go delete these other ones manually, right? So if you want option A, which is what we should want as any good database developer who wants like an atomic transaction, right? There are 2 options. I'm going to show you the first option that has more control, but it's a little bit more verbose. And that is, you can get a handle on the underlying database and actually begin a transaction. And when it's successful, you set that transaction successful, and then you end that transaction at the end. These things in the middle, they just participate then in that other transaction. So they don't have their own separate one. Yes?
Does Room have like an insert menu where you can pass like a collection of persons?
It does. I didn't show it. So like for this insert, this could be insert, and in Kotlin it'd be var arg space entities, and you could just, var arg space entities person. On the Java side, it'd be like person ... space persons or whatever, and it can insert all those. So that's one way to do it too. There's a simpler way to do it if it's all within a single DAO. Here I had this method as separate. You shouldn't consider for this example save people as part of the DAO. But if I move this method into the interface, wait, how does that work? Well, Kotlin, don't forget, you can add behavior to interfaces. But if you're on the Java side, you can also use an abstract class. Doesn't have to be an interface. And so you can add that method directly into there and add a transaction annotation on there. And that will run all of these in the same transaction, so you'd be at the same point. Questions?
So that solves your problem of being halfway through writing all the records to the.
Right.
Having like a halfway transaction is no longer a problem now. It'll be either all or nothing.
Right, all or nothing. And this is a trivial example, right? Like you have to imagine that you're really doing inserts across different tables. This is a transaction across the entire, it's like a real database transaction when you're doing it this way. I mean, they all are, but each of these three were individual real database transactions before. All right. So my verdict on Room. Room is freaking awesome. Try it out. Really, really, really easy to use. Great developer documentation. There's some really great videos. I never remember her name, but there's a lady in London who works for the developer relations team. Maybe somebody knows. I don't know. Anyways, Florina something. She is awesome. Watch her videos. She makes it very easy to pick up and run with this. My only message is remember the fundamentals. Remember that you're working with a relational database, and do the extra work to keep these relationships intact. Don't just, hey, query's fine, and let's run with it. Like, make sure you're thinking these things through. There's a few integrations that I think makes Room even more powerful that I just wanted to share. First off, has anybody used something called live data? Okay, so maybe a quarter. So live data is, for those of you who don't know, it's an observable container of data. If you've used RxJava, think of it, or if you've heard of RxJava, think of it like an RxJava Lite. It's less complex. It's easier to use. And the biggest thing about live data is it's lifecycle aware. So let's say, for example, I define my query method to return a live data of a list of people. Then if I use that from, say, an activity or a fragment, I could ask my DAO to find all people and observe using this action to fire off whenever those people update, right? And this isn't just for a one-time query. If there's any updates to the people in the database after my initial observation, I get another call. It's basically like an observer that just keeps on observing changes to the data set that was queried. The other cool thing about this is using live data tells Room to execute the query on a background thread and not block while it's running. And when that's done, the results get delivered back onto the main thread. One thing I kind of glossed over and didn't tell you about is by default, all of your DAO operations operate on the thread that you're on when you run them. So using this live data, I can push that work off to a background thread and get the results back in the foreground thread. Questions about how that works? How many people use RxJava? Okay, a few more. You can do almost the same thing with RxJava, and it supports flowables, so if you want continued updates to the data set after the original query, or singles, if you just wanted it a single time, but you wanted to push that work off to a background thread. It also supports the same thing for inserts or updates, basically any DAO call. You can have the return type be an observable result, and then you can control then the thread at which it does the query and the thread at which you react to it. In this case, in the subscribe block, it would come back to the main thread. So it works seamlessly with RxJava. You can also, like, as you're chaining these things together, with RxJava, a lot of times you're hopping back and forth between threads. All the objects can hop back and forth between threads, no problem. There's no issues with multi-threading and objects returned from Room. Okay, well, if there are no other questions, that's actually all I have for you today. So I appreciate your time. I hope you got something useful out of the talk, and thanks for coming.